let's discuss on transportation problem on today's lecture. In OM we have so many topics which talks about optimality and optimal solution. So finding the optimal solution will be our main aim to solve the problem. Like here also we are going to do the same case where we are going to find the optimal solution. Before that, we'll try to understand what do you mean by transportation problem. The word is very simple. We are going to talk about some transport related costs. So here is the main problem is I am supplying a few number of units or some amount of number of units which is being requested by the buyer. So the supplier has to supply from one place to another place, or there may be a manufacturer where this manufacturer has to give its supply to his supplier at low cost. So that's what we call as optimal cost. We cannot say it's completely low at cost. We'll maximum try to minimize the cost. So this is why it's called as a transportation problem. Again, to start with the problem, we need to check whether it's a standard problem. We need to check whether it's a standard problem. So for a problem to be a standard one, we have two checks. One is we need to check whether this is balanced. Balanced in the sense, if there are more supply and less demand, definitely it's going to go in vain. Or less supply and more demand, definitely it's going to go in vain. So in that case, we are going to check whether it's a standard problem, saying that it is a balanced one. It is a balanced problem, right? Second one, obviously we are talking about transportation cost, so it has to minimize it. So the second check is whether it's a minimized problem. So we need to have two checks on the standard problem, saying it's a balanced and it's a minimized problem. If not a balanced problem, obviously we can make it balanced. If not a minimized problem, we can make it, that is in case it is a maximized problem, we can make it minimized. Let us go for a few problems one by one, discussing on whether it's in case it is not balanced or in case it is not minimized, in case optimality is not reached. Okay, we'll go one by one. I have a basic one single problem. Actually, this is the same problem. I have 3 times written the same question. This is problem number 1. This is problem number 1. I have the same question written for 3 times. The reason why I have taken one question for 3 times is, here in this transportation problem, we have like a 2-stage problem, which means that first stage will find the feasible solution. There is a basic feasible solution. First stage will find the initial stage, because this is the initial stage which calls this initial basic feasible solution. Obviously we are going to find the solution. Okay, our intention is to find the optimal solution, but here the initial basic solution need not be optimal, okay, and may be feasible in the sense that it may be more suitable, okay, suitable with respect to all the constraints, common or satisfying all the constraints. It may be a feasible solution, right? But still in this first stage the solution may not be optimal. So we may be finding only the initial basic feasible solution in the first stage. In the second stage, what we are going to do is we are going to check whether this is optimal. We are going to check for optimality. This is what we are going to do here. We will check for optimality. So it's like a 2-stage problem where we will go for the first stage, initial basic feasible solution, and the second stage we will go for checking the optimality, right? Fine. For finding the initial basic feasible solution, in short we will write this as IBFS. In finding this initial basic feasible solution, we have 3 methods. One method here is, we have 3 methods. One method is, we'll take the northwest corner and try to allocate it. So northwest corner method. The notation used is NWCM. Northwest corner method, NWCM. Some call this is northwest corner rule, so NWCR, so you can use it anyway. This is first case. There is first method, we shall find the solution. Second solution is there is second way of finding the solution is least cost method. We call this as LCM method, right? And the third method was founded by Ogle. We call this as Ogle. This is Ogle's method, and we have 3 methods, and from these 3 methods, after finding the solution, we'll go for the second stage, right? We'll go for the second stage to check the optimality. And Ogle's method seems to be having more approximate value, in the sense that most of the cases, or 50% of the case, you can say this is optimal. Okay, in some cases that 50% of the case may be optimal, remaining 50% only we will be having the solution to be found out, which may not be optimal. So comparing to these three methods, Ogle has given an approximate answer like so. This famously called as Ogle's approximation method. Ogle's approximation method. So in short we call it as VAM method. In short we call this as VAM method. So we have three methods to find our initial basic solution. First one, northwest corner rule. Second one, least cost method. Third one, Ogle's approximation method. That's why I have written the same question for 3 times. So for the first time I am going to work out using the northwest corner method. For the second case I am going to work out using least cost method, and for the third time I am going to work out with Ogle's approximation method. VAM method na sollu, Ogle's approximation method. The theme is very simple. First thing, you have to check whether it's a standard problem, check whether it's balanced. Order is important. Go for whether it's a balanced problem, then go for checking whether it's a minimized problem. You have to check the balance first, then only you have to go for minimization, because this transportation problem works only when supply is equal to demand. That's why we call this as balanced. Supply should be equal to demand or demand should be equal to supply, then only we call this as a balanced problem. Then obviously we are talking about cost, so minimize the cost, right? If maximization of some value is given, you have to make it minimized. We'll go one by one in order. This is a basic solution. So if you are trying to understand this question, I have depots here, which has 3, A1, A2 and A3, 3 depots. I have some units here, units B1, B2, B3 and B4, 3 depots and 4 units. And the stock is given for each and every depot. Stock is given for each and every depot. So stock 8 with respect to A1, 10 with respect to A2 and 20 with respect to A3. When you go for the units B1, B2, B3 and B4, this is a requirement given. Requirement in the sense that how many units are required by the first unit and how many by the second unit, so on. So requirement here is 6, 8, 9 and 15. To check whether this is a balanced problem, add the stock and the requirement. The supply and demand are equal. Check one. So if you check 8, 10, 20, so 38 you are getting, yes, okay. Check the requirement also, 8, 14, 15, 29, 38, yes, 38 you are getting. It is a balanced problem. This is how you can check this one. This is a balanced problem. Next is to check the minimized problem, whether this is a minimized problem. If nothing is given in the question, it's a minimized problem. Probably your question here may be find the cost, find the minimum cost. So this is a minimized problem, right? If it is a maximized problem, it will be given in the question. So I have the 3 times written the same problem, which I am going to work out using the 3 methods, and I am going to find the total cost using this method, using LCM and using VAM's method. Let us check who is giving the approximate value, right? Fine. Let me go for the first case. The rules are very simple. Here with respect to northwest corner, allocate panna porom. Okay, from where we are going to start allocation. They have given a simple rule, go with the northwest corner. Okay. Here they have given, go with the least cost. Ogle's has given a different method other than Ogle's approximation. We'll go in detail. So if you go for here, the first case, if you see the table, the body of the table, excuse me, the body of the table, this corner, the top left corner will be taken as a northwest corner. The top left corner. So the top left corner is here. Is it okay? This is the top left corner. This is the northwest corner. We'll try to allocate it. Try to understand the problem. This cell is with respect to B1 and A1. Am I right? B1 and A1. B1's requirement is 6. A1's stock is 8. B1 kevla veno 6 units veno. And A1 has a stock of 8. It's very clear. Its requirement is only 6, but A1, the depot A1 has more of stock. So allocate the full requirement to B1. So I'll allocate the whole 6 units to B1. Is it okay? Whole 6 units to B1. So now there is no more requirement from B1. So make it 0. A1 totally had 8 units of stock, but now it has supplied 6 to B1. So it has remaining 2 units. So 2 units. Idella konchu clear up, no, you should not leave it alone. And there is no other requirement to be supplied by A2 or A3. So we'll just strike off this value. The striking off, drawing line is striking off that, removing B1. Hereafter, consider for B1 and remove pananu. So this is quite important, right? Next we will go for the northwest. This is why it's called as northwest. Go for the top left corner, top left corner. So this is the northwest here. Here the requirement for B2 is 8, whereas it can supply only 2 units. Am I right? A1 has already supplied 6 units to B1 and it has a remaining of only 2 units. Whereas the requirement for B2 units is 8, but still northwest corner matlab northwest corner will be allocated. So 2 units will be allocated here, so this becomes 0. 2 units get allocated here. And now this becomes 6, am I right? This becomes 6, right? Fine. So we can cancel off this one, strike off A1, which means that A1 has no stock in hand hereafter, 0 stock. That's why I got 0 here, right? Now comparing the remaining table, there is remaining body of the table. Northwest corner is this one, fine, this one. This requirement, that is the requirement for B2 now is, already it was 8, but it got supplied from A1 2 units, so remaining 6 units are under requirement, and A2 has a stock of 10 units, so no problem, you can supply the whole. So 6 units totally are supplied to B2 from here. So here there is a remaining stock of 4 and there is no more requirement for B2, so 0, right? Fine, try to understand please. So hereafter no need to worry about B2, strike it off, right? Strike it off, right? Remaining table, just these 4 columns are left out. Again go for the northwest corner. The name suggests this, northwest corner, eppome northwest corner, right? Whenever you repeat the process, go with the northwest corner. It seems very easy like. So you have 4 units in A2 depot. The requirement is 9 units from B3. Obviously only 4 units could be supplied by A2. So supply all the 4 units here. Is it okay? Supply all the 4 units here. And the remaining will be 5, right? Remaining will be 5. So you can strike off this one and strike off this one, right? Fine. Remaining only 2 cells left out, and the northwest corner rule is this one, says this one you have to select for. So here there is a 5 requirement, 20 in stock in A3 depot. So 5 requirement, just allot 5. So this becomes 0. Now 5 is allotted, so remaining stock is 15 and strike off this one, right? This is how you can do step by step. And only 1 cell remaining, obviously that is taken as the northwest rule, northwest corner, and 15 and 15. See, that's why we check this is a balanced problem. If this is not a balanced problem, we will not get equal number of supply and demand. So there will be a mismatch in the values. That's why we have to check whether it's a balanced problem. So you can allocate 4 of 15. Is it okay? You can allocate 4 of 15. Now you have to find the total cost. So we'll find the total cost. We'll find the total cost, which is, this is 2 rupees 6 units, 2 rupees and 6 units. So 6 into 2 with respect to first one. We can go in any order, either row wise or column wise, anything is okay. Now this one, 3 rupees and 2 units. So with respect to 2 units, 3 rupees, right? So first row done. I'm just going depot by depot, right? Second A2, 3 rupees and 6 units. So 6 units, 3 rupees, right? Plus here 4 rupees and 4 units. So 4 into 4, right? Plus next one with respect to A3 here, 7 rupees and 5 units. So 5 into 7 plus, and the last one 2 rupees 15 units. So 15 units into 2 rupees. You have to multiply and add everything. So it's 12 plus 6 plus 18 plus 16 plus 35 plus 30. So if you check, this is 18, 18, 36, 117. So it costs rupees 170. Please check whether it's given in rupees, just rupees, or rupees in thousands, or rupees in lakhs, whatever it is. I have not mentioned anything, so I am just taking this as 117 rupees, right? So 117 rupees is the value with respect to northwest corner method. Is it okay? Now let us work out the same problem using the least cost method. Okay, the name itself suggests least cost. If table name the least cost, go and select that one. Okay, table name the least cost, go and select that one. So I have to check each and every time. When I repeat the process each and every time, I have to check the whole table. Here it was, we are checking only the northwest corner. Here each and every time we'll go for checking the whole table. Again, if you go here, I find the least cost in 2 cells, 1 and 1. the values given in the body of the table is the cost values. Evlo rupees, how much it amounts, how much it costs to transport from this place to this place. So I have one here, which means that this is the least cost. Again, if there are two ones, no issues, you can take any ones, okay. So let me go with this one because I am just going row wise, anything you can take. So if you check here with respect to A1 and B4, the requirement for B4 is 15, but there is only 8 in stock. Please allocate it 8. So this becomes 0 and this becomes 7. You should be clear in subtracting the values. And this one is no more in discussion. So strike it out. Then striking alla konja clear up pannidunga. Next, go for the least cost. Remaining area la least cost. So here is one again. Here is 8 requirement, but 20 in stock. A3 depot 20 in stock, but only 8 requirement. So please allocate it here. Is it okay? So this becomes 0 now and this becomes 12 now. Yes, clear. So B2 goes away. Next one, that is next least cost. So after 1 we have 2 here. Okay, this 2 is already striked out, we cannot do anything. So I have a 2 here. So I can allocate it here. So 7 is there and 12. So 7 could be allotted, which means the requirement is 7 and stock is 12. So 7 could be done. So 7, which is 0. Is it okay? So not 0, 5. Very sorry, this is 5, right? Okay. So you can strike off this B4 now. No, nothing to do with B4. Now go for the remaining values, which is not striked out, and select the least one. So we have 7, 4, 4, 7. So we have only 4 as the least value, and there are 2 4s. You can take any 4. So let me go for this 4. You can take anything. Let me go for this 4. Here there is 9. Here there is 10, which means that 9 requirement for B3, but 10 is stock in A2. So you can give all. So 9 being allotted. So this becomes 0 and this becomes 1. Is it clear? So nothing to do with B3 hereafter. Closed. Next with here, only 2 values left out, 2 cells left out. The least one is 4. So here is 5 and here is 6, which means all the 5 in the stock of A3 may be allotted to B1, so that now the requirement for B1 is 1. Okay. Is it okay? So you can strike off this one, and the only value pending is 7. If it is a balance problem, this value has to match. Yes, nama check pannidunga. Yes, it matches because it's a balance problem only. So you allocate full 1. Is it okay? Now find the total cost. Now find the total cost. Shall we? So let me go row by row. Here it is 8 units for 1 rupee. So 8 into 1, right? Plus 7 rupees 1 unit, right? Plus 4 rupees and 9 units, 9 into 4. Plus here 4 rupees and 5 units, 5 into 4, plus and 1 rupee with 8 units. Is it okay? Is it okay? Fine. So this is 8 plus 7 plus 36 plus 20 plus 8 again. Fine. So the value here is 93. Yes, you can check the value. This is 93. So this is rupees 93. Is it okay? So this value is under LCM method, least cost method. First method we were working with northwest corner method. There was no logic. It's taken blankly. Or unskilled person, eppadi vandu direct edu modalla kedikudho adu work பண்ணுவாரோ அந்த மாதிரி. There is no any logical application. Whereas in the case of LCM method, yes, it is more logical in the sense that enga selavu kammi agudho, where the transportation cost is less, it will go and work out over there. Okay, so comparative is lesser, 117 and 93. Okay, idu compare பண்ணும்போது இது லெஸ்ஸா வந்ததுனா August method is named as August approximation method. Shall we make a check how he is doing here? Yes, fine. I'll have the board free for you. Let me explain the steps one by one and I'll work it out. And I'll have the steps aside for workings, writing the steps. He used something called as penalty method. It's very simple. He'll find the difference and he'll choose the most difference, right? He'll find the difference and he'll choose the most difference, right? Fine. So here VAM is using the penalty method, or you'll call this as iterative method also. He'll go iteration by iteration. What he does is, he goes row wise and column wise. Each and every row, he chooses the last, that is least element, and the next least element. Try to understand least element and next least element, and subtracts and writes a penalty value, right? Subtracts and writes a penalty value. He repeats for every row and also every column. From that value, he goes for choosing the most penalty value. Okay, let me work out and explain simultaneously. So I have here first iteration for row also and for column also, right? For row and also for column. So if I go for the rows, least value is 1 and the next least value is 2. See, each and every row, choose the least and the next least value. Least and next least value. Probably I may have the values written here, rules or with respect to VAM method. Okay, least and next least. Just subtract least and next least value and find the difference and put it here. So first roller with respect to A1, 1 and 2, least and next least. So the difference is 1. Okay, this is how you can do it, right? With respect to A2, 3 and 4, 3 is the least value, the very next least value is 4, so 1, right? A3, 1 and 2, least is 1, next least is 2, find the difference. Yes, it's 1. Is it okay? Fine. Here, least is 2, that is with respect to column. Next least is 4, 2 and 4, so the difference is 2. Find the least, find the next least, find the difference and place it here. With respect to B2, 1 and 3, so least is 1, next least is 3, so 2 here, right? Okay. With respect to B3, 5 and 4, so 1, 4 and 5, so 1. With respect to B4, 1 and 2, so here 1. This is how we'll find, or we call this as penalty method. Least cost எவ்வளவு ஆகும் A1 க்கு with respect to depot பாத்தீங்கன்னா, because row wise பார்க்கிறோம் இல்லையா, with respect to depot. If you check row wise with respect to depot A1, least costல B4 க்கு supply பண்ணலாம். In case B4 க்கு வந்து அந்த அளவுக்கு requirement இருக்கு, but நம்மளால வந்து 8 தான் supply பண்ண முடியும். Okay, in case B4 க்கு supply பண்ண முடியலனா, because we are checking for optimality, not just the solution, optimality, right? So in case it's not possible to supply to B4, the next possible may be B1. இதுதான் மீன் பண்றாங்க. Cost and next cost. So எவ்வளவு higher cost வருது? Okay, this is what we call here. Likewise we do for A2, we do for A3, and likewise B1, B2, B3 and B4. So least, next least, find the difference, put it in here. So this is the first penalty we'll give. And from the overall values, take the highest penalty. Okay, take the highest penalty. Okay, highest penalty means highest number. We check 1, 1, 1, 2, 2, 1, 1. So 2 twos we have, there's a tie-up. You can check anything, you can take anything. But usually what we do is, we go something closer to this. Okay, closer, that is leftmost எடுக்கிறது நம்ம எடுப்போம். Leftmost எடுக்கிறது எடுப்போம். So this is my first iteration's value. Is it okay? So I have 2, 7 and 4, 2, 7 and 4, right? இதுல least value என்னமோ அது எடுக்கணும். Please try to understand. This is the column I am going to focus, because this has the highest penalty, and when there is a tie-up, we'll go for the leftmost. Okay, this is the having highest penalty and leftmost. In this column, because I am focusing this column now, in this column, the least cost is available here. Right? Now check the requirements and stock. 6 and 8. Okay, so you can allocate whole of 6 here and 2. Is it okay? We are requirement of B1 is 6, stock at A1 is 8, so all the 6 units are allocated to B1, so only 2 units remain in the stock of A1's depot, right? So hereafter nothing to do with B1, strike it out. அதே மாதிரி தான் இங்க என்ன பண்ணோமோ அதே தான், but இந்த penalty மட்டும் தான் extra consider பண்றோம். That is, in the first case we took blankly without any logic northwest corner. Here we try to do something with least cost. Here what VAM is doing is, least cost whole table எடுக்கிறதுக்கு பதிலா we'll column, or we choose some row or column and we'll go for finding the least cost. So before using this method, least cost method, he is trying to allocate or he is trying to focus on particular rows or column. This is what VAM is doing. It's a beautiful method. Okay. So we have striked out B1. Now we have to continue the same thing. So this is now iteration 2. The same has to be continued with respect to. So the same has to be continued with respect to second time rows and columns, right? Rows and columns. 1 and 3. So the value is 2. 3 and 4. The value is 1. 1 and 2. The value is 1. The same thing. Next least find the difference and post it. The second iteration with respect to column wise, nothing to do here. So you can have a dash, right? With respect to B2, 1 and 3. So it is 2. With respect to B3, it is 4 and 5. So 1. With respect to B4 is 1 and 2, 1, right? Again, we have posted the values, we have posted the penalties. Now choose the highest penalty. Okay, so if we go for the highest penalty, we have here 1, 2 here and another 2 here. So 2, 1, 1 dash, which means you need not consider hereafter. B1 is not in discussion. 2, 1, 1. In this case, again, you can choose anything, but I am going to choose here with respect to row. Is not, there is no any hard and fast rule like, but in the 2 choose one, it will be more comfortable. Okay. So let me go here. This is with iteration 2 I am choosing here. This is the least cost. Okay, this is the least cost. Okay, this is the least cost. This is the least cost. Requirement is 15 for B4, but only 2 in stock. Please allocate the whole of stock to B4 and remaining will be 13 now. Is it okay? Remaining will be 13 now. Nothing to do with A1 hereafter. Strike it out. So when I go with the third iteration, it will be having a dash here. Okay. Again, I have to continue with the third iteration. So let me do with the third iteration. Okay, third iteration. Already nothing to do with B1 dash. Here, this one is striked out, this one is striked out. Only 2 values here. So obviously, I have to take the direct values 2, 3, 4, and here it is 1 and 1. Is it okay? 1 and 1. Go for finding the highest penalty. Yes, this is the highest penalty. So this is my third case. Now this is entering, which means I have to focus on this column. Inga we are focusing on this column. Here we are focusing on this column. The same thing we are going to do. We will find the least cost where it is 2 and 13 units are requirement for B4. Allocate all the 13. So remaining will be 7 here. All the requirement being satisfied. Nothing to do with B4 hereafter. So probably in the next iteration you can have a dash. Okay. And here we will go with the next iteration. You may have a doubt, how many iterations you have to carry forward? Maximum 4 or 5. So maybe this may be the last one because all values are close. That is either should be cancelled or allocated. Okay. So for each and every column I have to have lines. Okay. So this is how I can do it. So I am in the fourth iteration. Nothing to do with B1. Yes, B2 I have 2 values. Please find the difference. With respect to B3 is 2, is 3, yes, fine. With respect to fourth iteration, nothing to do here, okay. With respect to this column 3 and 4, so is 1 again. And with respect to this one 1 and 7, it's 6 here. So if you check here, the highest value is here. So this is with respect to fourth iteration, right? This is with respect to fourth iteration. So this row I have to focus on. Here it has 2 values, 1 and 7, right? 1 and 7. So the 1 and 7 you allocate panningana, 1 ku allocate pannu. Okay, least value is 1, least cost is 1. Here 7 only available in stock, but 8 is a requirement. No issues. Just give all the 7 here. Nothing in stock now, but the requirement here is still with 1. Is it okay? Fine. So now we can cancel this. Nothing, no more is required. Obviously, two values are no need to continue with the iteration. Only you can stop here. Iteration means that the process will repeat. That's what we call as iteration. We'll use the word called as iteration. Iteration, we have a set of process here. Find the least difference, next to least difference, subtract it, post it. That's what we call as penalty. Choose the highest value. This is a set of process. This process will be repeated until we'll reach a certain stage. That's what we call as iteration. Iterative method because we just repeat the same process each and every time. So almost the problem is done. You need not go for the fifth iteration because we have only 2 values left. Obviously, least cost is 3 here. So if you go for the least cost 3, 1 is required. So allocate. This becomes 0. So 9 will be left out. Nothing to do with B2. And here 9 and 9. See, it has to match. 9 and 9 match aglana. It's not a balanced problem. In case balanced problem on the 9 and 9 match agala, you have done something wrong na to probably small miscalculations might have been done. So konja calculation check panikiradu better. So 9 and 9, so I allocate the full here. Is it okay? Okay, is it okay? So I had to find the total cost. Let me go for finding the total cost. Okay, fine. With respect to rows, you go in any order, there is no hard and fast rule, you can go in any order. Let me go for this case first. 2 rupees and 6 units, so 6 into 2 plus 2 into 1, right, plus 1 into 3, right, plus 9 into 4, 4 rupees and 9 units, plus here 7 into 1, 7 into 1, plus this one 13 into 2, right. So you have to multiply and add all the values. 12 plus 2 plus 3 plus 36 plus 7 plus 26. 72, 74, 74, 83, sorry 74, 81, 83, 85. Okay, let me check the answer. And I am getting 85. 85, it's given 86. 13 into 2, 7 into 1, 9 into 4, 1 into 3, 2 into 1, and so 12, 2, 3, 6, 36, 7. Yes, it's 86. So it's 86, you can check the answer. So this is in the case of VAM's method. This is in the case of VAM's method, Vogel's approximation method. Yes, you can compare the values. In the first case, northwest corner rule, your answer was 117. In the LCM method, your answer was 93. Yes, the answer is 93. And in the third case, your answer is 86. So, in the pathing first stage where we have found the initial basic feasible solution, the first problem itself, the first stage itself says this is the best solution, like, but still we cannot say it's optimal. Best ingadhu vera, optimal ingadhu vera. Okay. So next stage. So this is stage 1 we have done, where we have found the initial basic feasible solution. Initial basic feasible solution. In the next stage, we are going to check for optimality, which means that we are going to check. Obviously, we are not going to consider these two now hereafter. We are not going to consider these two because this is somewhat seems to be suitable. இப்போ இங்க 86 arrive ஆயிருக்கும்ல, இந்த value கரெக்ட்டா check பண்ணது optimality. Okay, we have a certain number of steps. Okay, let me discuss one by one what you are going to do here. என்ன பண்ண போறோம்ங்கறத பார்க்கலாம். Before that, I'll erase the board and I'll have the allocated table alone here. I'll erase this full side. The iterations எல்லாம் இனிமே நமக்கு தேவையில்ல. I'll just have the main table with allocations done, right? In the next video we'll continue.